But yes, today we are talking specifically about RTK and drones, and they said this is a continuation. Not quite. This is actually a very totally separate topic that can live completely independently from the last topic about drone hardware. That said, if you are interested, I've got my email address at the end. You can shoot us an email, and we are recording all of these on video for anyone else at the office that might need them, or if you need the slides or that sort of thing. So with that, let's dive right into RTK and drones and PPK and GNSS and GPS and GLONASS, et cetera, et cetera, et cetera. All drone RTK data. So what we are covering today is similar to the last session. Everything we've learned from processing over 10,000 drone projects from companies all across the country, all different drones, all different GPS workflows, and basically all different possible circumstances for how a drone might interact with RTK or PPK data. As we talk about workflows, we're going to talk about a handful of other things, though. We're going to talk about not just the technical aspects of how to process PPK and that sort of thing, though we will get there, but really how to evaluate a good workflow. What makes a good workflow for RTK and PPK? What part of it comes from the office setup? What part of it comes from software? What part of it comes from the hardware that you own? And what part of it comes from how you set it up and in what order you do all of these things? That means, yes, we are going to go over the hardware and setup choices a lot, because that actually is, when we talk about workflows for post-processing data, most of that is going to be determined by the hardware you have and how you choose to set it up and connect it. This one's going to get a lot more technical than some of my other presentations, in part because there are a near infinite number of permutations that you can do for how you are post-processing, how you are managing GPS data. Hopefully some of you guys are pretty familiar, as surveyors, are familiar with the different workflows you can use to post-process regular GPS data, because all of the principles are exactly the same. But the applications and the differences between a drone and a GPS rover will make the workflows quite a bit different as well. So then we are going to talk about actually processing your GNSS data. And just to cover a couple things for people that might not be as much experts, GNSS is the fancy lingo term for basically all GPS data. GPS is the specifically American satellite constellation. GNSS also encompasses the Russian and the Chinese and the Indian satellites as well. Global Navigation System software. I should probably know what that is an acronym for. Satellite systems, there it is. Global Navigation Satellite Systems. So for those of you not super familiar, GNSS and GPS, I will oftentimes use them interchangeably, even though they technically are not, and I'm very aware of that. But colloquially, it's GPS processing at least, so excuse me for that. And we're also going to go over a couple recommended complete workflows. As I mentioned, it's such a complex series of interrelated parts and multiple options and permutations that I can't go over every possible workflow to get good data, but we have a couple of recommended ones of how you should go through your setup to actually get to the right data that you want, and what ways are focused more on saving time, what ones are more on reliability and resiliency, and all of those sorts of things. A little bit about myself and about us is at Aerotos, we do drone data processing for surveyors. Customers fly a site, send us data, typically photos, RTK data if it's there, and ground control points and LiDAR data now a lot more too, and we process the data. Which means that we have a pretty unique perspective because we get to see into the underlying workflows of hundreds of different companies, of different surveying companies out there. We get to see all of the different permutations of how they set up their base station, how they connected it to a base station, which base station we use, and how we get to post-process all of that data. And importantly from that, we get to see which workflows get used a lot because they're actually successful and reliable, and which workflows look really great on paper, but then don't work that often, or cause all kinds of but with post-processing issues or things like that. Excuse me. So that's our perspective. That's part of why we have this ability. We get to see so many more projects than most people because we work with surveyors all across the country. Sorry, excuse me. A little bit about myself. I am the CEO and lead photogrammetrist at Aerotos. I come from a formal education background in finance and statistics, which is part of why I actually love photogrammetry. It's just a bunch of data, and why I actually love GPS processing too, because I'm the type of guy that can actually open up a 10 gigabyte Rhinex file and be excited by trying to make sense of all of it and figure it out. I'm a geek, I'm a weirdo like that, and I love it, but I'm here to hopefully show you the ways that you don't have to do all of that stuff as well. And my goal today, if you've seen my other presentations, my goal is actually the same thing. Even though buying a drone is a totally different process than choosing a PPK workflow, but my goal remains the same. It's to help you build a drone program that you will actually use. And that, much like buying a drone, means that I'm not going for the absolute most cutting edge thing out there. I'm going for something that's a workflow that makes sense for your business, that doesn't require a PhD level statistics degree in order to say where your drone was and in order to do an ALTA survey of the latest Texas roadhouse that was just built or something like that. You shouldn't need a PhD in statistics to do that. My goal is to make workflows, help you choose workflows that are reliable and easy to use, and importantly, saves you time. When we get into RTK, I mean, really any new technology that's out there, you start adding new data, you start getting more different types of file formats, you need to buy more software. The vision is always to save time, but in practice, that's not always how it works, because you get all of this more new data, and you're like, great, I can save an extra 3 hours in the field because I didn't have to have people walking around doing extra control points. And then when you spend an extra 8 hours, or sometimes, depending on how much time you have available, an extra couple of weeks trying to process this data, well, all of a sudden that doesn't save you time anymore. And so for me, I only really like talking about workflows that are actually going to save you time, and importantly, ones that get you better data as well. There are always trade-offs with the quality of data that you need. Some things get really, really good data, and some things maybe not quite as good, but they might be good enough. And that's what we're going to talk about here today, too. In fact, I should say one of the things that I commonly hear from people whether it's buying a drone or how to fly the drone or what type of RTK processing is, I want to get the best data quality possible. And that's not always necessarily what you want, especially when I say, okay, best data quality, that means this project site will run you about $1.5 million. Say, oh, maybe what's the second best data quality that I can get? There you go. You want good enough data quality, but better data than you could before on simple workflows. And really, that's my goal. I want a drone program that you use. Again, I always like to be honest about my conflicts of interest, that we're a company that only makes money when people actually use their drone a lot. And that's what my goal is, and hopefully aligns with yours, is so that you can use your drone successfully, that's in a way that saves you time and money. That's what you want. A couple of more just kind of basic concepts with all of my thoughts. Number one, I don't like research programs. I like business. Or rather, I do kind of like research programs because I like the data a lot, but I realize that's a horrible business and not a good way to recommend about all of the, PhD level cutting edge. How are you working with all of these different phase center offsets and the things that make an open solution work and all of that stuff. I like making workflows that actually work reliably in the broadest set of circumstances. And likewise, there is no right solution for everyone. With GPS and with RTK, there are so many different ways to do it. And much like with drones, there is no one right way to do it. Different sites might have different access to different technologies. You might, as a surveyor, have access to different technology. And then there are just all the real world constraints of different tech that breaks. And so you have to change the workflow, or things that didn't work exactly as intended. And so it needs to be more resilient. There are some workflows that are easy, some that are very, very technically challenging and require that level of skill in GPS post-processing. Some will work absolutely anywhere on the planet. Others work great in certain circumstances. Maybe you're limited by baseline distance to a permanent station. Maybe you're limited by where your VRS network has coverage. Maybe you're limited by where the CORS network is, or maybe not at all. Some methods require prep beforehand, whether it's measuring and knowing the coordinates of a precise point before you actually go up and set up your drone program in the field, and others are more flexible and you can calculate that after the fact. Ultimately, different companies can have different workflows, and that's totally okay. So if you don't agree with my workflow, that's probably fine, but there are some bad workflows out there of ways that just don't quite get you as good data as we think is possible. And there are a lot of workflows out there that will totally chew up your time and really make you wish that you weren't processing GPS data anymore. But our goal, my goal today, is to help you avoid a lot of that stuff. All right, so for starters, let's start with some basics. How does RTK slash PPK, real-time kinematic, post-processing kinematic, actually, I'll take a step back as we are in the basics, just to make sure that we're all on the same terminology with the lingo. I usually don't actually like acronyms because they carry a lot of information to people that are very familiar and not with others. RTK, real-time kinematic. That means it is processing the data, the GPS data from a base station to a rover in real time. Post-processing, PPK, is post-processing kinematic, is doing the same calculations after the fact, typically in the office, not in real time. RTK means real time, PPK is post-processing after the fact. But beyond that, it's similar basic concepts. The way that it all starts is that you have a base station, and this is courtesy of ArcGIS, this basic thing. You have all of your GNSS satellites up top. They talk to a base station, which is a fixed point that is receiving those satellites, which then streams via some sort of radio transmitter an RTK connection to the rover. The measurement of the difference between the base and the rover is extremely precise, not accurate. What makes it accurate is that you know the known point here. So if the distance between here and here is very, very precise, and you add that with the accuracy of the known point, that's how you get accuracy in your rover. These are this is the basic concept of all RTK and PPK, right? The base station, it is on a known point, and everything is measured relative to that base station. That relative precision is very, very high, typically on the order of a few hundredths of a foot or centimeters, because everything in GNSS is typically in centimeters, even though surveyors work almost always in feet. Another thing that I'll admit I struggle with is at a survey conference, I want to say everything in feet and tenths and hundredths. And then when you're talking GPS, everything's in centimeters and meters. And so forgive me if my lingo gets a little bit mixed up there as well, because usually I talk in tenths of feet, but this is on the more scientific side. So this is your basic workflow. Anyone that has worked with GPS should probably be familiar with this. Now, you should also know that there are a lot of different options, right? This base station, where is it? Do you set it up over your site? Do you set it up over a point that you know in advance? Or do you calculate that point based on the radio or based on the observations that it's taking and calculate it later? If you're using a VRS network or any sort of post-process permanent base station, then this base station might not be on the same site with you. It might be 10, 20, 30, 40, 50 miles away. Or a virtual reference station combines a lot of those to create a virtual base station that doesn't even exist in the real world. But where this base station is, we're already getting really, really complex with the workflow here. And we're going to add one more layer of complexity by, instead of having just a base and a rover, we're going to have a flying drone moving around as well. So a GNSS workflow overview for a drone, the way that this typically works is, well, you have your drone and its GPS or GNSS or RTK module or whatever, which typically is going to be, for any of the modern ones, a high quality dual band GNSS receiver. And then that is going to talk typically via some form of radio or Wi-Fi. There are multiple different methodologies that it can talk to a local base station. And the local base station is going to stream those corrections. So just like with this, with here, you have your base station and your rover. With the drone is effectively the rover. And so that's where, when we get to processing terminology, a lot of times when I say drone data, I might also say rover data, because that is what, when it comes to the terminology used in a lot of the PPK software, the drone is effectively the rover. And what it is communicating with is a local base station that is streaming that real-time kinematic data and getting that over to the drone, so that the precision, the relative accuracy of that drone relative to the local base station is very, very tight. I should also point out there's a lot of other stuff going in here, which I'll talk about too, that it's, even when that works really perfectly, much like how if you use just like a Trimble unit as a rover on a job site, the GPS itself is actually only calculating the location of the antenna phase center of the unit, and then you have to do the phase center offsets and rod height offsets to actually measure the ground. The drone's a little more complicated because it's still getting the antenna phase center, but now it's attached to a gimbal. So the offset the distance and angle between the antenna phase center and the camera changes and moves all the time. Thankfully, the software is very, very good to do that sort of lever arm adjustment pretty much automatically. But if you go to PPK workflows, you might have to do some of that manually, which is a bit of a pain. We'll cover that in a little bit. But this is your basic workflow. So the drone talks to the local base station. Now, the local base station may or may not be over a known point in advance. And so oftentimes that has to talk to a permanent base station, whether this is a public US government provided service that gives out the permanent base station, or a private network or a state-run network, core stations. There are a bunch of permanent base stations. Some survey offices have permanent base stations on their physical office, which is pretty cool. And that can stream corrections to get a known point in the job site with the local base station, which then streams corrections to the GPS. You can see we're already getting a little bit more complicated here. And the other alternative that a lot of people do with workflows, or that a lot of people pitch with workflows, but hopefully I will convince you out of today, is to actually correct your drone as a rover directly with a permanent base station. This can be done in two different ways. This can either be done in real time via a internet connection, right? Wi-Fi connection to a VRS or a network correction service of some form, or it can be done purely in post-processing, where you have your Rhinex file from the drone and you have your Rhinex file from the base station, from a core station, and you run all of those in post-processing. What I will cover with these a little bit later is I don't like this because drones are much, much, much more sensitive to long baseline distances than rovers, a standard survey rover. And part of that is with a standard survey rover, if you're working with network corrections, you can take a measurement and you take usually a couple seconds observation time, multiple seconds, and it'll say if it doesn't have RTK fixed, so you just wait another couple of seconds or 10 or 20 or 30 seconds until you get an average good point. The drone doesn't get to do that because it's moving at 30 feet per second and it's moving extremely fast. If you drop even just a couple seconds of internet connection, well, then you're in trouble. Or if the satellite quality wasn't really, really good, then you're in trouble. It just introduces a lot more noise. It is very capable to get network-based corrections to a drone, but from a survey standpoint, it's not the accuracy that I really want. We'll get into that a little bit more in detail later. But all of these kind of options, this is really the basic workflow of what can talk to each other. But even within this, what hardware you use and how these things talk to each other and how they process are pretty challenging. But that's just for GNSS too. One of the things when we are talking about GPS post-processing workflows, the most common way that drones actually get their accuracy and precision for a drone survey is through ground control. People say, oh, well, do I need ground control if I'm using high precision, high accuracy GPS and a really high quality workflow? Well, good RTK and PPK, good being a very important word there, good RTK, not all RTK is good yet. Good RTK and PPK is absolutely technically capable of producing survey grade accuracy without ground control. However, we do not recommend it. In the real world, we think that no ground control on a job site is simply not good enough. Ground control is required if you want to properly calibrate the camera, because even if you have perfect RTK data, that tells you where the antenna phase center is, and what you care about is where the ground is. In between that, there's a drone, a gimbal, a camera lens, and then the ground. And so making sure all of that is together is just challenging. Not impossible, but challenging. You need it to localize your project. Not every site is measured in WGS84. Not every site is measured in pure NAT83. You often localize over a known point on the ground. And using ground control is a really, really great way to do that. And that can save huge amounts of time in the post-processing workflow, as opposed to trying to create site-specific datums and then import that into your RTK and that sort of thing. That can be a pain in the butt. And also having the ability to detect errors is a really, really good part of ground data. So human error, it really just remains common in the more complex RTK, PPK workflows. And some of you guys are pros and probably saying, I don't make mistakes, and good for you, but a lot of people do. And so I'm just trying to be honest from our perspective is that we see human error a lot, whether it is from the RTK or the drone or the PPK or just fat fingering a number in when you're trying to type in the dates of a core station or whatever. That really happens a lot. And ultimately, as we're kind of going into depth, I should point out this stuff, GPS and PPK, can get really, really complicated. There are people that are PhDs and dedicate their lives exclusively to this sort of thing. So there's a real deep learning curve here. So please, I encourage you, ask questions, raise your hands if something doesn't make sense. You probably won't become a GPS expert overnight, though I hope that you will know a heck of a lot more about the fundamentals of the workflows and how it all connects. And if you need, talk to an expert. Companies like Aerotas, like us, that's what we do. We process drone data all the time, including for RTK and PPK. That's our job, so you can always talk to us. All right, so to actually get into things, first of all, how do you evaluate a good workflow? When I talk about PPK workflows, rather than jumping right into the start of what makes or of what a good workflow looks like in terms of tech, I want to help you evaluate how to evaluate a good workflow on your own so that you can choose your own workflow, right? Again, my goal here is not to tell you how to process your data, but to give you the tools so that you can pick the right way for you and for your jobs how to evaluate it. So some factors to consider. Well, different workflows have different levels of accuracy. Some surveys need really good accuracy, 1/10 of a foot or better. Other surveys might be able to get away with a few tenths of slop, and other surveys, maybe you just need imagery, and if it's off by a foot, you're fine as long as it's plus or minus a foot or something like that. And if you only need plus or minus a foot, then you have a heck of a lot more simple options available to you than if you need a 1/10 of a foot. And that's not knocking people that need a foot accuracy. There are lots of applications, especially if we get a little bit out of a survey, a little bit more in the GIS world, where a foot is totally good enough accuracy. And that can be done on huge sites for real cheap versus 1/10 of a foot accuracy over 100 acres is going to be a little bit more challenging to achieve. Also, reliability of a workflow. This is going to be one of the most interesting ones because when I talk about reliability, there are two real factors that I go into. Number one is how often it works properly. That means you show up, you do follow the steps of the workflow. Did it work? Yes or no? Did it work or did it not work because the core station that you were going to post process against was down for that day and you didn't know it, and the nearest public base station is 100 miles away, and that didn't work, right? Does it work on all sites? Were you planning to use a network correction and you show up on the job site and you have no cell service, and so that's not going to work anymore? Or let's say that your survey crew was supposed to mark a point and measure it in advance the day before of where you're going to set up your base station on a known point, and you go and you can't find the base station, or you can't access the known point or something. And so you have to either set up over an arbitrary point or you have to call the survey crew back or something. That's what I mean in terms of reliability. Because when it comes to the actual value of a workflow, one of the biggest time killers out there is field revisits. So having a reliable workflow that means you show up to the site, you gather your data, and you don't need to go back. That's a really, really key part to reliability. And honestly, it saves the post-processing team a lot of time as well. Also, what is the skill required to operate this? Knowing what your own skills are and what the skills of the people in your office are will dictate your workflow. If I talk about converting an RTCM3 data stream to Rhinex format, if that scares you, then you might be a little bit wary of post-processing raw GPS data. And you might want to go towards some more automated, simpler solutions. Or if that doesn't scare you, then yeah, feel free to dive into a lot more of the kind of granular data. But this goes into not all workflows are right for all people, and also not are right for all companies. A big company might have 5 survey crews, but only one person that really knows GPS this well. And so depending on how you want to set it up and for who you want to set up, that's important. And also time required as well. That is something you should factor in. Time required both in the field, right? If I told you, here's a great workflow, all it requires is that your base station take an 8-hour observation so that you can do the right post-processing on it. Well, that is going to be a non-starter for a lot of different companies where it's like, look, I want to be in and out in 20 minutes. How can I do this with a 20-minute observation, not an 8-hour observation or something on there? And of course, the cost of these things as well. There are multiple costs of how to both the equipment that you need, the software that you need, and the cost of labor. So to go over kind of our workflow again, this is what our workflow looks like. But even beyond this, there are a lot of questions, right? Network corrections or a local base? Are you streaming via internet, or are you going to stream via a radio signal direct to the drone? Real time or PPK? These are some of the questions that I'm going to at least answer. Do you do something that is real time, where it is you're in the field, it's streaming those corrections, or do you want to post process it entirely? I can tell you real time is generally going to be preferable for two reasons. One, because if you're doing it in real time, you actually have the real time feedback then that your signal quality is going to be good enough that you actually have a fixed geolocation on that. But if you're doing it in post processing, you might not know until after the fact that, oh, there were some data processing errors there. Likewise with RTK and PPK, if RTK comes back and it doesn't have quite the level of detail you want, you can still kind of fall back on post-processing. But if post-processing doesn't work, it doesn't work the other way around. So RTK is generally preferable. Moving base stations. This matters when you are working on larger sites. Typically with a lot of drones, you want the base station to be physically near the pilot, right? You set up the base station because that needs to stream corrections to the controller, and then the controller goes to the drone. But if you're doing a 10-mile corridor, heck, if you're doing 100 acres, you need to have multiple takeoff zones. You pack your stuff up, you go to the other site, and that means you now have moved your base station. That relative point at which the relative accuracy is very, very high, that relative point has now moved. So those two flights, each individual flight is accurate internally, but you're going to have to eventually get those back together somehow. And that's where we come into the post-processing, right, of how we are going to post-process all of those things. And do you do it by post-processing where your base station was? Do you post-process where the drone was? And what do you use to correct those against? That's what we're going to get into. Using things like Opus solutions, right? For those of you that are not familiar, Opus, oh boy, that's not one that I'm going to remember what that stands for. Beautiful, thank you. I'm so glad. Online Positioning User Service. That is going to be a public government-provided service for basically uploading raw Rhinex data and being given a very, very accurate point on the world. Relative to that, it's a very cool way of basically post-processing a single point against multiple known public base stations, and it does a really good job. But it certainly has its limitations too, in terms of how far it is from the base stations, and it requires some fairly strict requirements in terms of data format, how long the point observation time has been. And there are alternatives to that as well, just doing a single point static PPK processing. I've talked a lot about accuracy versus precision already, and I think it's important to really expand on this a little bit more. This is a common chart in comparing accuracy and precision, but this matters a lot because I am very precise, see what I did in my language, that RTK is very precise. And what that means, precise, precision, and relative accuracy are often used interchangeably. That means if you were to measure 3 points, the distance between those points would be very, very perfect. But the exact position on the planet Earth of those points might not be. Being exactly in the right place on planet Earth, that is going to be accuracy. Precision and accuracy are different things. So this is the example of something that is very high precision. You measure the same point 5 times and it's always exactly there. But there is a systemic bias from where you actually want to be on planet Earth, but each of those points are very, very tight. This one is going to be high accuracy because it is in the middle, but the precision, the individual points are kind of all over the place. So just as a reminder, I'll say this a lot, RTK typically when you are using it, depending on all of your other setup and workflows, but typically RTK is going to be very, very precise. And until you correct it against some sort of known point, like by getting an Opus solution or by doing post-processing against a known base station, that is going to be how you get your actual accuracy. So let's talk about this a little bit more. Again, I know I'm probably saying this too many times, but that's because this is one of the more important concepts in terms of choosing the right workflow. If you don't get a hold of what precision versus accuracy is, then you're really going to struggle with picking the right RTK or PPK workflow here. So how do you get precision? Precision is when you do RTK or PPK to an arbitrary local base station. That's where you take your base station, you set it up over an arbitrary point, and arbitrary means you just set it up anywhere, even if it's marked, unless you know exactly where it is and you code that into the base station, it still kind of counts as arbitrary. That gets you precision. Whereas how you get accuracy is, well, there are a couple of different ways. The first off is the one that I mentioned before, ground control points. That's actually the most common way to get accuracy, and one of the most common workflows is to not worry about having to post-process all of your GPS data from the drone, because the drone data is super precise, and you just use your ground control points to effectively shift it. It's precise, so you kind of do an offset to get it exactly to your ground control points, and that is how you get your accuracy, whereas the precision comes from the RTK data over a local base or an arbitrary base or something like that. You could also program your local base over a known point. That's where, instead of just setting up your base, I joke with in one of the previous things with like a DJI base, you take it and you just spear the whole pole into the ground and it'll stream your relative corrections. And honestly, it works. You don't even know where it is. Or you could set it up perfectly over a known point, key in the coordinates because you know those coordinates in advance. So now that local base almost becomes a permanent base in the sense that it's over a known point, it streams it, and then your actual image geolocation data in real time is both precise and accurate. That's a really good workflow as well, with the challenge that you actually need to have that pre-measured, pre-marked point that you know the exact coordinates of that one. Another option is to get an Opus solution on your local base station. You get your RTK data, you have your local base, and then when you get back into the office, you run post-processing, you get an Opus solution on that local base station to correct it from what its originally initialized position was to the Opus corrected solution, and that will give you an offset. You can apply that offset to all of the RTK data, to all of the image metadata, and that's how you get your accuracy. So these are all different ways to do it. Another way to actually get accuracy potentially is to correct your GNSS data to a permanent base station directly. And that's the one that I said we don't typically love with drones, but that means you're actually taking the drone's data stream itself, ignoring any sort of local base station, and post-process correcting it, or even potentially real-time correcting it to a permanent base station. And actually, I'll go back to this because this will tell you a lot of really good things. If you correct your drone directly to a permanent base station, you get this. You get high accuracy, low precision. That's what happens when you use network-based correction services on a drone. High accuracy because it's connected to a permanent base station, low precision because there are longer baseline distances. When you use an arbitrary base without any sort of corrections, any sort of PPK at first, you actually start with this. You start with very high precision and low accuracy, and then by getting either an Opus solution or correcting it to a known points or with ground control, you take this tight data and you shift it to the target. That's kind of what I mean by the offset. Does this all make sense? I know this can be a very good, all right, good. I'm seeing a lot of nodding. I'm not getting people too far off. And some methods, they have different trade-offs. Some methods are very accurate but take a lot of time. This is a chart from the Opus website showing the the root mean square accuracy depending on the observation time here. And what you can see is your rapid static solutions that will get you about 4 to 6 if it's under an hour or so, and then obviously 10 down to about a centimeter of accuracy for these really long observation times, which I would never recommend. Realistically, in survey, even 2 hours when it comes to drone flights, 2 hours is going to be a pretty long time. But herein lies some of the challenges of having an Opus solution, for example, because 2 hours is a pretty long time. Usually for a single drone flight, even 2 drone flights, that's going to be an hour or less. So for what it's worth, we often do a lot of these rapid static solutions in an hour. And this kind of 2 to 3 centimeters of RMS error is typically going to be good enough for most drones. And this goes back to that kind of question I had about accuracy, right? If you say I want the best accuracy, cool, enjoy sitting on a job site for 10 hours or leaving something there. Most people then say, well, I don't want to do that. How do I get good enough accuracy? And my answer is a 1 hour rapid static solution is going to be good enough. The other thing worth talking about is this is just the accuracy of the Opus solution, but then you have to talk about all of the other noise that comes in as well, because drones are not capable of 1 centimeter. 1 centimeter, that's what, 300ths of a foot or so. Drones, no matter, even if everything else is absolutely perfect, no drone is going to reliably get 300ths of a foot accuracy in the final data product. It's going to be a lot closer to this 2 to 3 centimeters, to about a tenth. What is that? A tenth of a foot is 3.5 centimeters, something like that. The conversions are not great. I think they're good enough. So that's where usually, again, your 1 hour rapid static solution for a single point for the base station is almost always going to be good enough. And this is why when I say, it's not just about the accuracy of the solution. When you're measuring accuracy, what we care about is the final accuracy of an entire system, of the accuracy of the base station, plus the accuracy of the radio link, the RTK to the drone, the baseline distances that are involved, the accuracy of the IMU, of how well calibrated the camera is, how clearly your ground control targets or check shots are marked, all matters. Single component accuracy, the accuracy of just the IMU or just the LiDAR or just the GNSS chip or just the base station, it influences things, but its full system accuracy is what really matters. And to measure that, what we use is the ASPRS positional accuracy standards. For those of you that aren't familiar, ASPRS, it's a nonprofit organization. This one I do know the acronym for, the American Society for Photogrammetry and Remote Sensing. Nonprofit, highly academic organization. They produce these standards that were last updated in 2014 that really are the gold standards for measuring accuracy. And they talk a lot about the accuracy of GPS and IMUs, but also what they really care about is when you're certifying accuracy on a project is the accuracy of that final system. And I should point out for anyone that works with ASPRS or knows about them, they are in the process of updating these. These were last updated in 2014. There is a draft currently out for the latest 2023 update, which will be, I've read through the draft at least, and it looks like it's just very good in acknowledging a lot of the ways that surveyors are using drone aerial technology. So check out ASPRS, they're a nonprofit organization. My only criticism of ASPRS is that they're super academic. A lot of times that makes using them in the real world a little bit more challenging, but their actual data quality and the science and information behind them is super robust. All right, next I want to talk about reliability a little bit more. Reliability I always have to define because this is what a lot of people think when I say there are workflows that have low reliability. And it was honestly the same thing in the drone world. I say, oh, it's not a very reliable drone. They're like, well, crap, it's going to crash. I haven't heard of any crashes. No, drones just don't really crash anymore. Reliability has become a lot kind of more boring thing, right? Because there are lots of ways to get bad data and for a workflow to be unreliable, not just, some equipment catching fire, right? No cell service at a site. That's an unreliable workflow. If your workflow relies on cell service and you go out to a super remote site in the sticks and you've got no cell service, that's an unreliable, broken workflow. Doesn't mean that anything caught fire, it just didn't work. That sucks. And now you have to figure out something new. You have to make changes in the field, which is always dicey because when you start changing your plan once you're already in the field, just the room for human error really goes up a lot. The closest public base station is down. If you were going to PPK something and you knew that there's a core station that's 5 minutes or 5 miles away, you say, great. Then all of a sudden, the site was down that day for whatever reason, right? This was obnoxious when there was the last time the government went through one of their usual political budgetary spats, and the entire cores network went down for like a couple of days when they defunded, or the Treasury defunded the government, and they furloughed everyone. They literally just turned off the Core's website so you couldn't PPK data for a couple of days if you were using any public base station data. The drone doesn't have RTK fix, and maybe you didn't know it. Depending on which drone hardware system you have, some of them you will have on your connection, you will say number of satellites visible, 22, RTK status, fix. That's great. Other systems are a little bit more black boxy than that. They don't have as much information that's live to you in the field. And it lost its connection, it lost its fixed solution, and it didn't tell you that until you get home and look at the data in the office, And all of a sudden, that means your data is not as good as you actually need it, and you're potentially in trouble. Or your equipment runs out of batteries, right? You have too much equipment. You guys, I'm sure, have seen this sort of thing before. That can be a pain in the butt. Or just the more mundane technical stuff. Your GPS base station and your drone won't connect. The Wi-Fi's on. This is searching for Wi-Fi. Why isn't it seeing it? What the hell? Turn off, turn on, whatever. That's my example of the very just mundane, annoying, unreliable workflows, but ones that, gosh, that's really hard to tell in advance which ones are going to be unreliable for things like that and which ones aren't. So when I recommend workflows and ones that we say are reliable, a lot of it is just from experience too, right? Hey, if you use this system, I can't even tell you why necessarily, but we've seen people in the field struggle with this a lot. And it might literally just be because they're turning their Wi-Fi on and off and on and off 100 times to get it connected. They say, F this, I'm out of here. And they just say, I'm shooting control instead. So that's where ours is very just kind of on the ground, what seems to work and what doesn't, or just, radio signal and interference and that sort of thing. What skills are required? This is one of the questions that I think you ought to ask when thinking about you or your company's GPS workflow is, are you designing this workflow to be operated by a single highly trained individual or for a business that might have multiple operations, or probably a better word is multiple operators? What software are you using? Is it an RTK Pro that is operating it? Do you only have one person who's the RTK Pro? Are you that one person that is the RTK Pro? I'd imagine in this room a handful of people are that person in the company that they know this inside out and backwards. You say these surveyors out in the field don't have a clue how any of this works. You might be that person, and that's totally fine. But ask yourself that question when we're designing this workflow. Are you designing it for a super highly competent or are you designing it for the new guy? Because a field surveyor left, need someone to go out in the field, collect GPS data, and I'll deal with it all in post. That matters when influencing things, right? We talk about Opus solutions. Even I forgot what the acronym was for. But being able to know what an Opus solution is, process it, and troubleshoot it when it fails, because a lot of them fail. Dealing with Rhinex data files. Rhinex are some of the more raw GPS observation files that you have to deal with. Working with public core stations, working with proprietary GNSS software. I'm looking at you, Trimble Business Center. Working with RTCM data stream encoding, which is one of the common encoding methodologies for how a lot of the GPS data, when it comes raw through these chips, is encoded. Are you familiar with those things enough to actually process them? And then also talking about time and cost considerations as well. So time, there are different parts of time that actually matter. Things like prep work and surveying that needs to be done first. I mentioned that before, right? With the setting a base station over a known point, if you have to send your crew out the day before to set up a known point on which you can set up your base station, well, that takes an awful lot of time, even if it saves time flying the drone. The amount of time marking and measuring ground targets. Some workflows are way more robust without RTK data, but require you to set a handful of more targets. Where that trade-off actually lies is really dependent on the job site and your crew and how you make these methodologies. There are some job sites where much of the project site is super inaccessible. Steep valleys, a lot of rocks, a lot of vegetation. You can't walk through it. There's nowhere to mark it, or for site restrictions, you're not allowed on site, so you have to fly over it. So you can't set ground targets. That means you might have to have a different RTK or PPK workflow to get your accuracy from the air and from satellites as opposed to from actually shooting targets on the ground. Alternatively, your crew might be super efficient and you're just doing a long highway corridor and you say, you know what? We've got our base station set up so well that we're going to go and we're just going to shoot a ground target every 500 feet because each additional target takes us about a minute in the field. Stop the truck, paint an X, shoot it, keep driving. In that case, great, set a lot of targets, and you're going to save a lot of time in post, and that sort of works well. Observation time, I kind of mentioned that with the Opus solutions, how long your base actually needs to be there. Again, if you're actually going to be running post-processing on your local base, I usually recommend at least an hour. Don't take that as the hard and fast rule. Your company may have different requirements. If you're setting up a local base and your company's policy is the local base must always have at least 2 hours observation time, that's fine. like that. You might say 20, 30 minutes is good enough. That's actually totally fine in a lot of circumstances as well. Post-processing workflow time, that really matters though. If you are doing a 2-hour observation time and you are recording data in your base station at 5 hertz, so one observation every 0.2 seconds, that's a massive amount of data. We actually talked about that in my last talk, and we should talk about it more here, even though I don't think I have any slides specifically on the, oh, I do have a little bit on the frequency of this. Drones, because they are flying so fast, take very, very, very frequent observations, typically at the speed of 5 hertz or one observation every 0.2 seconds. Static observations, especially if you're doing it for an Opus solution, are typically going to be 15 to 30 seconds of duration. And that means that a drone base station, a base station that is used to stream corrections to a drone, is gathering 150 times more data, more raw satellite data, than one that is sitting there as a base station for like an Opus solution or something like that. So we're talking huge scales of data that can influence your post-processing time as well. But then it's not just the amount of time. There's also, of course, the cost of processing this, the cost of your equipment, of the software that you're buying, again, looking at you, Trimble Business Center, and the cost of the labor, whether you are the GPS expert that's doing all of this, or if you are hiring the GPS expert that's doing all of this, the amount of time and labor that goes into a project site is what will often determine what makes a workflow successful and get used again on the next site, or if they say, nope, we're going back to traditional methods because this just takes too much time. All right, let's get into some actual hardware and setup choices on the overall GNSS system. Starting with, again, the workflow, there's the drone is the hardware, the connection methodology really matters, the local base station matters, and which permanent base stations you're going to use. As far as what drone to buy and whether or not it has RTK, see my other presentation. I just gave an hour and a half about drones earlier. That's super valuable. So you can shoot me an email there if you would like a copy of that presentation or a video of that. But to summarize some of our basic recommendations from before, RTK really ought to be included on any new survey drone. You can do no RTK processing and just use old school drones, but we think RTK really ought to be included on any new survey drone. That means Phantom 4 RTK and Mavic or Matrice 300, Mavic 3 Enterprise RTK, that sort of thing. DJI drones remain the best overall quality and value, and non-DJI drones all have trade-offs somewhere, but typically can deal with a lot of post-processing as well. Although admittedly, the non-DJI drones, we see a lot more people struggle with the post-processing there because it's typically a much more raw data format. Those are just, they record Rhinex data on the drone, they record Rhinex data on the base station, you put it into a kind of bespoke post-processing software to try and geotag the images, and it leaves a lot of room for human error on those sorts of things, whether you're typing your data in wrong, whether it's not over an assumed point or anything like that, whether the time sync between the actual drone and the images and the RTK, that's actually a big source of data too. Even at 5 hertz, taking an observation every 0.2 seconds, if a drone is moving 30 feet per second, over that 0.2 seconds between observation 1 and observation 2, the drone has moved 6 feet. That's actually a ton. When we're talking accuracy in the centimeters here, or at the worst, we want 1/10 of a foot or better, 6 feet is a monstrous amount of error and ambiguity, which means even at 5 hertz, which is really fast for a lot of GPS measurements, you're interpolating between 2 points 6 feet, and the drone might take a path that looks like this, that has a big bump in it, but if you're interpolating straight, that's another source of error because you're interpolating halfway between 2 timestamps that are 0.2 seconds apart, and that can make all the difference. So this is where it gets really complicated, especially when you're actually managing the post-processing yourself. Why I typically prefer letting these sorts of systems work in real time is because those systems are designed to handle a lot of those offsets in real time. Whereas if you're manually processing this data, you have to deal with a lot of the interpolation between those individual timestamps. As far as what local base station to buy, this is another important one that we covered a little bit in the hardware talk too. Well, option one is no base station at all, right? That means, well, either you do network PPK, network corrections, which I'll cover more in a bit, or you rely purely on ground control points, another totally viable way to work. You could also use the DJI DRTK2 ground base station. This one is interesting because it is typically not going to be as high quality as a actual Trimble or Leica survey grade GPS unit. It's designed for a single purpose, and that is to stream RTK corrections to a DJI drone. Again, see my other presentation for more details on this. It's very, very reliable and easy to use because you just push the on button, it turns green, and it connects. And it streams the precision, that relative accuracy to a drone very, very well. However, getting absolute accuracy out of the DJI DRTK2 can be a little challenging, and I'll cover that more in just a second. You can also use a third-party base station, Trimble, Leica, Geomax, Carlson, really anything like that. Most of those typically work. They just come with a more complex field workflow for connecting it to the drone. Or a permanent base station only, which is where you connect the drone. You don't have a local base station, and you connect the drone either through real-time via network internet connection or post-processing to a permanent base station, and that's not recommended. The ways that you connect a drone to a base station, well, you have the drone. Typically, just so people are aware, this kind of matters depending on some of the field workflows. A lot of them it doesn't actually in the field. The drone almost never connects directly to a base station. It does not have an internet connection. Typically, some do. Those are very rare outliers. But drones connect to the controller via a radio signal, and then the controller can either talk via Wi-Fi to a permanent base station. This is what your standard workflow is going to look like for network-based RTK. You do have a cellular internet connection that goes from the base station to the controller, typically via Wi-Fi or a phone hotspot somewhere in between there even. And then the controller talks to the drone. It's not the base station directly to the drone. Or your other option is the controller talks directly to the base station. This is the more preferred route, to have that local base station really having a lot lower, smaller baseline distances that improve accuracy quite a bit. To then go into a little bit just more detail, why we don't recommend network and permanent base stations only. I say only because doing post-processing against permanent base station, that's how most PPK is done, right? You take your actual rover or you take your local base station and you post-process that against permanent base stations. That is what the Opus solution is. The Opus solution is post-processing against permanent base stations. So that part of things is good. But using only permanent base stations is not great for drones. Like I said, the baseline distance is just too long for a drone. And I had another great question in the previous talk that I gave, which is, well, what baseline distance is too much for a drone? And it's a great question. It really, I've been thinking about that since, and how much I want to actually do more research to have a precise answer for that. And all I can tell you is that 2 miles between the drone and the base station, you're fine. That's short enough that you're going to see plenty good survey grade accuracy. If you're 20 miles or above, that is too long. I say too long for survey grade. If you're working in a more GIS oriented project where you can have a foot of slop, then network is probably the best solution for you, because network is very simple, right? You connect your phone to the internet and you can fly anywhere where you have an internet connection and have accurate data. And I say accurate, again, being very deliberate with my word choice. You can have accurate data anywhere, but those long baseline distances mean that you're going to see about half of a foot to a foot of slop. That's not the technical term, slop, but it'll work. But you'll see half of a foot or more of air, which again, if it's GIS applications, that's probably good enough. If it's survey applications, you're going to want it a little bit tighter, and that's why you want the local base station. Requires cell service to work. That's very dependent on your company, how often you're working in places that have no cell service versus whether or not you have absolute perfect coverage. Accuracy, it is not as good as RTK. It is also often overstated. That statement deserves a little bit more going in depth. All of these GPS systems are very, very intelligent in the metadata that they record. When it records an image geolocation, all of the modern systems record not just the geolocation, but an estimated precision of that geolocation as well. I say precision. These systems often screw up the terminology. They say it is their estimated accuracy, some do, but almost always the estimated error budget that it gives is the estimated precision on there. And when you're working with network RTK, what we have found in real world data is that network RTK solutions will overstate their estimated precision. If you use a local base station, it'll say this was what's it called? The metadata will say we estimate the precision on this to be 3 centimeters or so, and that bears truth. And then if you use network RTK, it says we estimate the precision to be 3 centimeters, and our statistics say, nah, it's closer to about 7 or 8 centimeters in actual real world processing. So it's often overstated. Baseline distance, just as a final summary, it's the distance between your baseline and the actual drone, the distance between those connections. So whatever you're correcting the drone against, how far away it is what that baseline distance is. And of course, with the drone, that changes all the time. You take off one place, you fly a mile away. Honestly, within a mile, it's all the same. That will have negligible impact on accuracy. It's once it starts getting 5, 10, 20 miles that we start seeing impacts from baseline distance. So as far as network correction services go, it is worth noting they are good for ground surveying. I'm not telling you not to use network solutions. If you use network solutions or network correction services for your base and rover, they are great for ground surveying because it's a different workflow entirely. You can take longer observation times, you can take multiple observations. It's static, it's not moving. Very, very good for a lot of ground surveying applications. It is also good for GIS level accuracy if you want GIS level accuracy, but it is not recommended for drone surveying. That's our professional opinion there. To talk a little bit more about the DJI base station and how it works as well, it's really simple. You turn it on, it calculates an arbitrary point. If anyone actually wants to know, it's a 10-second single solution, so it is going to be arbitrary, and then it fixes that in the headers of the Rhinex data so that it starts recording from there. But it's a single solution unless you code in the other solution. We'll cover that in just a second. All RTK calculations are streamed to the drone relative to that point. That point is available in the Rhinex data for the base station. You can calculate it. You can then do an Opus solution or post-process the data from the DJI base station as well. It is recorded in, part of the reason a lot of people don't like it, and this wasn't always known, it is recorded and encoded in RTCM3 format on the base station itself, which means only in some circumstances is this actually saved onto the drone. Like for the DJI L1 LiDAR sensor, it actually saves it in Rhinex, or actually I forget that one, but on the drone. But to actually access it, you often have to get it off of the base station itself, plug it in via USB, something like that. Not as much of a very friendly user interface there, which can be exported, even though that's kind of a pain. And the geolocations encoded to the imagery data when you use this base station are very precise, like I said, but not accurate. Any questions there? Because I know this is a weird base station. Yeah, what's up? Correct. I would not ever recommend using this for setting and marking control points because of some of the, well, one, it's just a real challenging tool to use. That's not what it's designed for, the software interface. If you were actually trying to turn it on and mark a control point, it'd be a pain in the butt. Two are things like build quality on this, which compared to any professional survey grade tool is just not up to snuff. Like I was mentioning, the leveling bubbles on this are like the size of a pinky nail, and they're not super level. So that means if you're actually trying to use it to set a known point, there's a good chance that you're going to be off, and you can't even attach it to your own driver. Anyway, it's not a good survey tool, but it's great for streaming network corrections to a drone. That's the way that I would recommend thinking about this. The DJI base station serves one purpose. It is the local base station for a drone. They try and claim on their website, oh, you can use it for other things. That's crap. You don't want to as a surveyor. You might technically be able to find ways to do it, if you love hacking with software, I think it's technologically possible, but no, it's a single purpose tool. You can, yes. There are some challenges. You can only give it WGS84 and only geoid height. No, only ellipsoidal height. That's right. Yeah, it has to be WGS84 with, I think it's, let's say, EG86 ellipsoid. That is the only thing that it supports code putting it in. So, and then everything else, all the outputs are still in WGS84. So it's a lot less flexible. And that's one of those challenges. That means when you show up to a site, before you turn the thing on, you must have it set up exactly over a known point, and you must know those coordinates in WGS84, which isn't always the case. That's just an additional step that you would have to do. So it's very doable. Typically, it's not a lot of people use that exact workflow because that's a bit of a pain in the butt. They're more likely to actually then use a third-party base like a Trimble or something, set that up over a known point, which is much easier to do. You can use your existing coordinate systems. You can use your existing workflow with that, and then deal with the challenging part of streaming that data to the drone. So there are little trade-offs there. Yeah. Great question. The drone itself always, always, always works in WGS84. That's how drones work. I have not seen any drone that operates in anything other than WGS84. And not to be too annoying with this, actually a lot of them work when they're working with Rhinex data. They're not even working in WGS84. That's another layer made more human accessible. They're working in like ECEF, like Earth Center, Earth Fixed, or something like that. Or, yeah, or Cartesian, or like specifically when you look at the Rhinex data, the raw data there is going to be like satellite clock times, right? So that there are so many levels of obfuscation that it's worth noting, whatever it's worth here. Basically, all image geolocation data is going to be WGS84 with ellipsoidal heights, and everything is going to be corrected after the fact from there, using different levels of software at different points. Part of the reason why, just to touch on a third-party base station, why you use that is it handles that level of obfuscation for you so that you can code in the coordinates in your coordinate system in that ADP over a known point, and then kind of let it handle converting that into the actual Rhinex data, which is then going to put it in, yeah, again, Cartesian, or I think, what is it, geolocations in Rhinex headers are usually ECEF format, the center of text. I could be wrong on that one. But anyway, third-party base stations are a lot easier there. The data quality is just as good in terms of how precise when streaming it to the drone is. More flexibility in setup and processing, no need for additional equipment, but setting it up is a pain. I mean, these are actual, I have a video that we even link to of things. The video of how to connect a Trimble R10 to a DJI drone is 10 minutes long. That's how long the tutorial video is to try and teach you how to do it, including things like what IP address to put in your ntrip host number, what port number it is, the username and password that you have to set up, as well as what ports your then Trimble is getting set up as far as outputting it. It's highly technical. It's not impossible. If you understand all that, if you're one of those guys that knows every menu option on your data collector, awesome, go for it. But it's just not accessible to absolutely everyone. As far as where to position your base station, a couple of things like that. We've already talked about this. You can set it up. Oh, sorry, question in the back. Great question. So the way to use a DJI base with that workflow is do what I kind of said, stab it in the ground, arbitrary point, doesn't matter. It streams the corrections to the drone, which are precise. And you start with just the precision. And if you are in a fully local or arbitrary coordinate system, our recommended workflow would be to use ground control points. To take that process, mark your ground control points, and shift it, basically translate it to get your accuracy from the ground control points. So the precision comes from the RTK, and the accuracy comes from the ground control points. So you wouldn't, our recommended workflow there would not be to create a custom datum such that it works in in your custom coordinate system, because you might not always have those, the exact definition for that custom datum. But rather, it's a much simpler workflow. Set a couple control points and then shift the data when processing your photogrammetry to actually get it into that coordinate system. Does that answer your question at all? Yes, exactly. Yeah, you don't need as many ground control points, and you can also interpolate over further distances. For example, that if you imagine theoretically you have a 2-mile corridor, you could get away with 2 control points at either end, or even just like 3 control points, 2 at one end, 1 on the other, and it could be fully arbitrary, right? A 5,000, 5,000, but because you have RTK, that whole thing, the precision is fixed, and you literally just rotate it and scale it accordingly to get it to fix in your local system. That's the idea behind it, and it allows for a lot more kind of flexibility in that workflow, where RTK still provides that check on things like human error, right? If you set 3 control points and one of them shows up randomly 6 feet off the surface or 6 feet below the surface, it says, oh, maybe someone set the rod height wrong, something like that. It still provides a big benefit. Mm-hmm. Yeah, so that's where there are 2 different ways to do it. One, you can get a post-process solution on the DJI base station itself. The other is you can actually use those 2 different flights. You can process them separately and localize them separately as well when you have multiple flights. That's very, very common for larger workflows, and I actually have a slide that's specifically about the workflow for DJI base station over arbitrary flights or over arbitrary points with multiple base station moves, because there are a couple different workflows that you can use for that too. And that goes, as far as where to position it. Like I said, you can process it. You can set your base station over an arbitrary point, which is precise, but needs GCPs for full accuracy. That's what we were talking about. You can also set it up over an arbitrary point, but you make that point accurate with either PPK solutions. I'm doing a static post-processing solution on the individual base stations and then offsetting the flights. That's one methodology. If you do have the Rhinex data from the base station, run PPK or Opus or anything like that, that just requires a little bit more post-processing. Or, like we mentioned, you can set it up over a known point. That means it has to be previously surveyed, coded into the base station. Slightly more challenging field workflow, but also sets you up for a little bit more reliability down the line. Of course, you have to make sure it's right, too. Anytime you're coding in a number, you're opening yourself up for any sort of fat finger errors or something like that. Worth acknowledging that is another just challenge. Moving on to actually processing the GPS data, because I want to make sure we have time to get to the final workflows as well. Honestly, one of the most important questions I think you can ask in how to process final GPS data is ask yourself, do you really need to actually manually post-process the data? This is going to sound like I'm saying something stupid and obvious, but the fastest way of post-processing is no post-processing at all. If you don't have to post-process, that's a really good way to post-process, because that's going to save a lot of time and money. You need no software and no time. What a brilliant thing. But seriously, it's worth asking the question, do you need to process it? Like I was saying, from trying to get something into an arbitrary coordinate system, the most efficient workflow is use your RTK for precision and just use ground control points to effectively shift the whole project. That's a really, really effective way of skipping some of the post-processing stuff there. The real-time GNSS processing is typically done in real time on the drone and often negates the need to post-process. If you were set up over a known point, you shouldn't need to do that. Or if it was precise, you might only need to post-process the base station. You shouldn't need to post-process the drone. Post-processing the drone itself can be really, really challenging. And then asking yourself a question, and this isn't even a hypothetical or anything, which takes more time, setting control or running an Opus solution? That's a sincere question that is going to be different on different jobs. Sometimes, if you've got everything set up, shooting a few more control points might take a couple of minutes. Processing via Opus, you might need to wait a day or sometimes 2 days, depending on exactly what time of day it is and whether it hits the right clock to get your rapid ephemeris the same day or whatever. So a lot of times, setting control using your existing field workflow is going to be a faster method than running everything through post-processing. But knowing how to post-process can help, especially if something went wrong in the field and your data was incorrect for one reason or another. Asking yourself which parts you will post-process really matters too. Are you processing the drone screen as the rover against the local base, the base station? Or are you processing the local base against a static network base? In this case, your local base station is technically the rover, and this is where the terminology gets really confusing. Your base station is actually the rover, and the core station or the public base station is going to be the base in post-processing terminology. In that one, you can do a static process, which is going to provide a single point and typically going to have much, much higher accuracy than any of the kinematic style processing, which is where the drone is actually moving and every point it is in a completely new place. Are you going to process the drone stream, the drone's raw Rhinex output, against a static or network base? That's one that's going to be one of the more challenging ones because the drone, like I said, it's a kinematic stream. It's moving around. It's ticking and bucking like crazy against a static network base with longer baseline distances where we see you aren't typically going to get the highest quality results there. Or are you just going to use your RTK precision geolocations and offset them by a fixed amount? Knowing what your planned workflow is before you fly really helps. In fact, if anything, that's probably one of the biggest takeaways that you can get from this is know what workflow you're going to do, right? Don't just say, we're going to go out, we're going to take a bunch of data, say, no, we're going to set it up in arbitrary, and we're using GPS's location to fix it. Again, I promise I'm getting to the recommended workflows pretty soon. So again, this is our kind of just that slide you've seen a bunch, the different GNSS workflow options. So one of the questions that that people ask a lot is what software out there is there out there for post-processing? And honestly, there's not a lot. There are only two that I'm personally familiar with that I'll be talking about. The first is one called RTK LIB or RTK Library that's actually an open source software. Part of the reason I like this is, well, it's open source and it works pretty well, but it's a pretty high learning curve. It's very low level. There's a lot of need to understand all of the different settings and the different types and different ways to mess it up. But part of the reason we like it is it's all RTK and it's fully open source. Now, anyone who's worked with open source software probably knows it has a lot of trade-offs. One, it's super powerful, but two, the documentation and support is not great. You need to be very comfortable making errors and not knowing why there are errors out there. The other extremely common thing out there is Trimble Business Center. It's more popular, easier to use. It's a lot more expensive, not open source at all. And it has a lot of other tools that many surveyors use. Being honest, I don't use Trimble Business Center that much because I don't like their photogrammetry engine personally. I don't actually love their GPS processing engine for my applications. I don't work it for a lot of survey work. It's absolutely wonderful. I know people that swear by it, and that's fine. I work specifically with drone-based GPS, and I do not like their drone GPS post-processing workflows. They have some things that are really nice where it tries to automatically download DRS data or automatically download core base station data, and that's cool. But when it doesn't work out perfectly, it just kind of doesn't work at all. I've found that with open source solutions, they're harder to use, but they can often provide slightly higher levels of accuracy. You can automate some of the open source ones. So I like open source. Other people swear by Trimble Business Center. It's not the right thing for me, but these are definitely going to be the two most common GPS post-processing software that I'm familiar with. Does anyone else in here use a different GNSS post-processing software? Do you like Infinity? Do you like it or? Okay. Cool. No, and that's I want to know if there are ones that I'm missing that other people are super familiar with, because these ones I definitely see both of these a lot. Trimble Business Center, by far the most popular, I would say. RTK Library, the popular of any open source thing, but yeah, again, it's a little bit more of a pain in the butt. Because for using, this is like one of the user interfaces for RTK Library and what it would look like processing PPK data over a static point. So you start with your rover data, which is going to be Rhinex data from the local base. So you actually have to have your Rhinex data from the local base, your quote base data, which I screwed up the quotes on the slide, is going to be the RINEX data from a permanent base station or core station or something along that would look something like this. You can already see this is getting a little bit technologically challenging because you need to typically download manually the public base station data, or if you have your own base station, you can use that. But putting that in there, making sure your settings and options are all set up so that you know, oh, the initial location of the base station is embedded into the headers of the RINEX file. Cool. And then things like your satellite ephemeris data, this is all going to be provided by NASA, which is your exact locations and clock timings of the actual satellites as they were flying, and then process from there and review what the actual results are. One of the biggest things is what the actual quality, whether or not you had a fixed integer solution on your post-processing. The biggest thing that we have found in the biggest determining factor in whether or not a RTK or PPK, or rather whether or not a PPK solution gets a fixed integer solution is baseline distance. That is the number one easiest thing that you can change. Shorten your baseline distance, you have much higher likelihood that you are going to get high quality fixed integer solutions on your PPK processing. That is true completely between open source and Trimble stuff. We have done bake-offs between their two different softwares and that sort of thing. And it's not that much different, honestly. If something fails in one software, it's likely to fail, or if it's low quality in one software, it's low quality in the other. That's our experience. I'm sure the Trimble sales reps will say something otherwise, but that's kind of what our experience is. PPK on a moving point, so on the drone, same basic setup, except your rover data is going to be the drone data, and your base station data is going to be the RINEX files from the whatever base station you're using, whether it's the local base station or the permanent base station. Like I said, we talked about before, when you are processing a moving point, it's very, very, very sensitive to observation frequency. 5 hertz, 5 times a second is what we would recommend for drones. It is possible, I should point out, when you are doing PPK processing, to have a 5 hertz observation data from the drone and only 1 hertz, 1 a second, or even 5 or 15 or 30 hertz on the base station. That is absolutely possible, but you start, when the age of the clock timing starts to get beyond 1 or 2 seconds, you do see a little bit of error and drift in that sort of thing. So it's why I say 5 hertz is recommended, but it's not absolutely required. You still can post-process your drone kinematic stream against a 1 hertz or even 5 second or 15 second observation times. You absolutely can post-process them still, and you are going to get better than nothing accuracy, but it's not going to be as good as that like RTK precision from a local base. Another thing that's worth noting, when you are PPK processing on a moving point, converting the drone PPK data to image geolocation takes additional steps. This is something that's often overlooked on PPK because you do correct this RTK stream and you get, a beautiful set of timestamps and geolocations, but the image center is offset via lever arm and that camera gimbal relative to the GPS antenna. And as I mentioned before, interpolating those movements for sub 0.2 seconds is going to be so critical, so critical to get the level of precision that we actually care about. Dealing with those offsets, there are a handful of softwares and like pre-built templates to kind of handle it. It's possible to do this sort of thing in Excel if you're really good at spreadsheets and math and that sort of stuff, because it's not insanely complicated, right? You look at the timestamp of the photo, you look at the timestamps of the geolocation before and after, 40% of the way through, so you create a 40% weighted geolocation that does a straight line interpolation across. Yeah, there's definitely some mathematics involved there, and there's a lot of room for error, and that's part of why that makes it more challenging. You can do this, and oftentimes we will do something like this as a last resort if for whatever reason a base station may have failed or you don't have local base station data. We can do this and to get better accuracy, but this isn't what I would recommend as a workflow straight out the bat. So as we were running out of time, let's actually walk through a couple of what we would recommend our sample kind of complete workflows is of how to set up in advance what workflow you're going to use for setting up and processing your data. A couple of things, there are some limits to our recommended workflows. all of our recommended workflows require some level of ground surveying. Remember what I said before, that we think that just out of responsibility, all surveys need to have some ground data. That means that when we're designing a workflow, we are operating on the assumption that there will already be a field crew there. This at some point, right? It doesn't always have to be before or after. It's flexible timing wise, but we think that this needs to be boots on the ground. That's why these are recommended for surveyors. If you're just a drone service provider and you don't do survey whatsoever, you want to fly out, fly a drone and get everything without ever bringing out a actual tripod, well, we don't think that's the right way to actually do survey. We think it needs to have some level of ground data. We're trying to balance the accuracy, reliability, and ease of use and optimize those against one another. We're not trying to max out one single thing and say, screw cost and time, it just needs to be right. That's not to say that there aren't circumstances where that is what you need to do. And again, there are edge cases that can require custom workflows if you are outside of areas covered by known base stations. If you get called up to do something in rural Canada and there's no base station, public permanent base station within 200 miles, you're going to have a very different workflow than anywhere within the continental United States, at least. So let's start with the simplest one, right? I want to bring up this workflow, GCP, Ground Control Point Focused Workflow, because it's actually more common than people think. For something that's all about RTK and PPK and drones, it's worth noting a workflow that doesn't use any airborne RTK or PPK is still totally viable, and a lot of people do it. No use of RTK or PPK at all. All accuracy and precision is derived from the ground control points. It's ridiculously simple, ridiculously reliable, and ridiculously cost effective. But it does take a lot more time in the field. You need to set more control points, quite a few more than you ever would. And it's not going to be the best quality accuracy because you don't have that RTK for the precision. It's the other way. I should say no precision, but it's not the best precision, more accuracy. So that's kind of your ground control point focused workflow with no PPK. This is one of the more common workflows, and we actually like it a lot. This is RTK plus a local base station over an arbitrary point. So you fly an RTK-enabled drone with a local base station, and you set up the base over an arbitrary point. This is because that workflow is super simple, right? You set it up, you turn on your DJI base station, you don't code anything in, it's arbitrary. It produces extremely precise results. It's a very flexible workflow because you don't need that information beforehand, and it's very low technical requirements because, again, you push on and you fly it. The problem is the results are not accurate. The accuracy in this workflow is going to come from your ground control points. So you actually take that data from the arbitrary point and use that for precision and ground control points for accuracy. This is by far the favorite workflow among field surveyors because it is so damn simple in the field. It works just about everywhere. You don't need cell service. You don't need anything like that. It just kind of works in the field. But it does produce challenges for the office workflow because the results are not accurate. The next suggested workflow is RTK with a local base that is PPK processed. So what this means, you have an RTK-enabled drone with a local base station, same as before. The base is set up over an arbitrary point. Again, you're still not setting it up over a known point. But the base station location is post-processed with either PPK for a static solution or as an Opus solution, and the offset is applied to the photo geolocations. It is both accurate and precise. It is still a very highly reliable workflow, but the challenge is that it needs good base station data, which you don't always have, depending on the DRTK2 and your settings and all of that. Pulling the Rhinex data off of the base station can kind of be a pain in the butt. And PPK processing takes time, and it can delay the project. I mean, like I said, even with Opus solutions, a lot of times there's a day or two before you can get the data to process it, so that'll delay a project by a day or two, yeah. Great question. You're actually, in this case, just processing the local base, so it technically wouldn't be a kinematic, it'd be a static solution on the base, but the drone and image geolocation would still be from the real-time kinematic processing that was between the drone and the local base. So you're correct there. So this is, it's becoming a little bit more popular. Like I said, this is the most common because it's so just darn simple in the field. This one is nicer on the office folks and a little bit more work on the field folks. So again, kind of balancing your trade-offs and that sort of thing. Which is better? I like them both. They both produce perfectly acceptable quality results. That's why we kind of recommend both of these. There are also some workflows that work, but we don't love. Full PPK, so post-processing kinematic, this would be kinematic processing against the drone. We don't love that. It leads to a lot of field revisits and is very time consuming because of having to calculate a lot of those lever arm offsets. We will do that as when necessary, but this is not our favorite workflow. It is possible. Setting up a base station over a known point, it is going to get you a lot of good accuracy, but it requires a lot more planning and not as much in-field flexibility. If you show up, the point's not marked properly, or you need to take off from a different location because it's further away and there wasn't another known point, it produces a lot less in-field flexibility that we don't love. PPK on the drone, drone rover, Rhinex, all the PPK stuff directly with the drone, highly complex and lots of noise in the final data. And just to kind of wrap things up, you can use different workflows. Different workflows for different sites is perfectly acceptable. Different field techs might use a different workflow that they're most comfortable with, but it's operationally very complicated. And we usually like to see, when we see companies that are more successful, they have the same workflow throughout. I'm going to skip just a couple last slides. And obviously, we help land surveyors with drones. That's what we do. So if you want drone setup, mission planning, LiDAR, all of this, if you're confused, send us your data. We'd love to process it. And lastly, if you would like a copy of the slides, a video of this presentation, if you have any other questions for me, please feel free to shoot me an email, logan@aerotos.com, and I'd be happy to answer it. With that, thank you so much for your time and attention today. I really appreciate it.